Welcome back. I got up very sleepy today. Now it's 11, soon 11 a.m. So I made a lot of video about old Jedi airliners. So let's reading. The heating is on. So let's read this. I need a minute to do my ready. But that will take a few weeks to read all this. This old Jedi, I need to read many of this Comet, Havilland, and Russian one, Boeing 77707, DC-8. I read this a long time ago, but now I will read it again. I need 30 seconds to get to my bed. But many of these old airliners that's still flying around, like the old Airbus 300 and the old Boeing 737 Classic, they still fly around every day.
De Havilland Comet. This article is about the jet airliner. For the 1930s racing aircraft, see de Havilland DH.88 Comet. Comet, aircraft, redirects here. For other aircraft called Comet, see Comet aircraft. The de Havilland DH.106 Comet is the world's first commercial jet airliner. Developed and manufactured by de Havilland in the United Kingdom, the Comet 1 prototype first flew in 1949. It features an aerodynamically clean design with 4 de Havilland Ghost turbojet engines buried in the wing roots, a pressurized cabin, and large windows. For the era, it offered a relatively quiet, comfortable passenger cabin and was commercially promising at its debut in 1952. Within a year of the airliner's entry into service, 3 Comets were lost in highly publicized accidents after suffering catastrophic mishaps mid-flight. 2 of these were found to be caused by structural failure resulting from metal fatigue in the airframe, a phenomenon not fully understood at the time. The other was due to overstressing of the airframe during flight through severe weather. The Comet was withdrawn from service and extensively tested. Design and construction flaws, including improper riveting and dangerous stress concentrations around square cutouts for the ADF, automatic direction finder, antennas were ultimately identified. As a result, the Comet was extensively redesigned, with structural reinforcements and other changes. Rival manufacturers heeded the lessons learned from the Comet when developing their own aircraft. Although sales never fully recovered, the improved Comet 2 and the prototype Comet 3 culminated in the redesigned Comet 4 series, which debuted in 1958 and remained in commercial service until 1981. The Comet was also adapted for a variety of military roles such as VIP, medical and passenger transport, as well as surveillance. The last Comet 4, used as a research platform, made its final flight in 1997. The most extensive modification resulted in a specialized maritime patrol derivative, the Hawker Siddeley Nimrod, which remained in service with the Royal Air Force until 2011, over 60 years after the Comet's first flight. Development, edit. Origins, edit. On the 11th of March, 1943, the Cabinet of the United Kingdom formed the Brabazon Committee, which was tasked with determining the UK's airliner needs after the conclusion of the Second World War. One of its recommendations was for the development and production of a pressurized, transatlantic mailplane that could carry 1 long ton, 2,200 pound, 1,000 kilograms, of payload at a cruising speed of 400 miles per hour, 640 kilometers per hour, non-stop. Aviation company de Havilland was interested in this requirement, but chose to challenge the then widely held view that jet engines were too fuel-hungry and unreliable for such a role. As a result, committee member Sir Geoffrey de Havilland, head of the de Havilland Company, used his personal influence and his company's expertise to champion the development of a jet-propelled aircraft, proposing a specification for a pure turbojet-powered design. The committee accepted the proposal, calling it the Type 4 of 5 designs, and in 1945 awarded a development and production contract to de Havilland under the designation Type 106. The type and design were to be so advanced that de Havilland had to undertake the design and development of both the airframe and the engines. This was because in 1945 no turbojet engine manufacturer in the world was drawing up a design specification for an engine with the thrust and specific fuel consumption that could power an aircraft at the proposed cruising altitude, 40,000 feet, 12,000 m, speed, and transatlantic range as was called for by the Type 106. First phase development of the DH.106 focused on short and intermediate range mailplanes with small passenger compartments and as few as 6 seats, before being redefined as a long-range airliner with a capacity of 24 seats. Out of all the Brabazon designs, the DH.106 was seen as the riskiest, both in terms of introducing untried design elements and for the financial commitment involved. Nevertheless, the British Overseas Airways Corporation, BOC, found the Type 4 specifications attractive, and initially proposed a purchase of 25 aircraft. In December 1945, when a firm contract was created, the order total was revised to 10. During the next few years, the UK has an opportunity, which may not recur, of developing aircraft manufacture as one of our main export industries. On whether we grasp this opportunity and so establish firmly an industry of the utmost strategic and economic importance, our future as a great nation may depend. Duncan Sandys, Minister of Supply, 1952. A design team was formed in 1946 under the leadership of Chief Designer Ronald Bishop, who had been responsible for the Mosquito fighter bomber. Several unorthodox configurations were considered, ranging from canard to tailless designs. All were rejected. The Ministry of Supply was interested in the most radical of the proposed designs, and ordered 2 experimental tailless DH-108s to serve as proof of concept aircraft for testing swept-wing configurations in both low-speed and high-speed flight. During flight tests, the DH-108 gained a reputation for being accident-prone and unstable, leading de Havilland and BOC to gravitate to conventional configurations and, necessarily, designs with less technical risk. The DH-108s were later modified to test the DH.106s power controls. In September 1946, before completion of the DH-108s, BOC requests necessitated a redesign of the DH.106 from its previous 24-seat configuration to a larger 36-seat version. With no time to develop the technology necessary for a proposed tailless configuration, Bishop opted for a more conventional 20-degree swept-wing design with unswept tail surfaces, married to an enlarged fuselage accommodating 36 passengers in a 4-abreast arrangement with a central aisle. Replacing previously specified Halford H.1 Goblin engines, 4 new, more powerful Rolls-Royce Avons were to be incorporated in pairs buried in the wing roots. Halford H.2 Ghost engines were eventually applied as an interim solution while the Avons cleared certification. The redesigned aircraft was named the DH.106 Comet in December 1947. Revised first orders from Bork and British South American Airways totaled 14 aircraft, with delivery projected for 1952. Testing and prototypes, edit. As the Comet represented a new category of passenger aircraft, more rigorous testing was a development priority. From 1947 to 1948, de Havilland conducted an extensive research and development phase, including the use of several stress test rigs at Hatfield Aerodrome for small components and large assemblies alike. Sections of pressurized fuselage were subjected to high-altitude flight conditions via a large decompression chamber on site and tested to failure. Tracing fuselage failure points proved difficult with this method, and de Havilland ultimately switched to conducting structural tests with a water tank that could be safely configured to increase pressures gradually. The entire forward fuselage section was tested for metal fatigue by repeatedly pressurizing to 2.75 pounds per square inch, 19.0 kPa, overpressure and depressurizing through more than 16,000 cycles, equivalent to about 40,000 hours of airline service. The windows were also tested under a pressure of 12 psi, 83 kPa, 4.75 psi, 32.8 kPa, above expected pressures at the normal service ceiling of 36,000 feet, 11,000 m. One window frame survived 100 psi, 690 kPa, about 1,250% over the maximum pressure it was expected to encounter in service. The first prototype DH.106 Comet, carrying Class B markings G5-1, was completed in 1949 and was initially used to conduct ground tests and brief early flights. The prototype's maiden flight, out of Hatfield Aerodrome, took place on the 27th of July 1949 and lasted 31 minutes. At the controls was de Havilland Chief Test Pilot John Cat's-Eyes Cunningham, a famous night fighter pilot of the Second World War, along with co-pilot Harold Tubby Waters, engineers John Wilson, electrics, and Frank Reynolds, hydraulics, and flight test observer Tony Fairbrother. The prototype was registered GALVG just before it was publicly displayed at the 1949 Farnborough Air Show before the start of flight trials. A year later, the second prototype G5-2 made its maiden flight. The second prototype was registered GALZK in July 1950 and it was used by the Bork Comet unit at Herne from April 1951 to carry out 500 flying hours of crew training and route proving. Australian airline Qantas also sent its own technical experts to observe the performance of the prototypes, seeking to quell internal uncertainty about its prospective Comet purchase. Both prototypes could be externally distinguished from later Comets by the large single-wheeled main landing gear, which was replaced on production models starting with GALYP by four-wheeled bogies. Design, edit. Overview, edit. The Comet was an all-metal low-wing cantilever monoplane powered by 4 jet engines. It had a 4-place cockpit occupied by 2 pilots, a flight engineer, and a navigator. The clean, low-drag design of the aircraft featured many design elements that were fairly uncommon at the time, including a swept-wing leading edge, integral wing fuel tanks, and 4-wheel bogie main undercarriage units designed by de Havilland. 2 pairs of turbojet engines, on the Comet 1S, Halford H.2 Ghosts, subsequently known as de Havilland Ghost 50 Mk1S, were buried in the wings. The original Comet was the approximate length of, but not as wide as, the later Boeing 737-100, and carried fewer people in a significantly more spacious environment. Bork installed 36 reclining slumber seats with 45 in, 1,100 mm, centers on its first comets, allowing for greater legroom in front and behind. Air France had 11 rows of seats with 4 seats to a row installed on its comets. Large picture window views and table seating accommodations for a row of passengers afforded a feeling of comfort and luxury unusual for transportation of the period. Amenities included a galley that could serve hot and cold food and drinks, a bar, and separate men's and women's toilets. Provisions for emergency situations included several life rafts stored in the wings near the engines, and individual life vests were stowed under each seat. One of the most striking aspects of Comet travel was the quiet, vibration-free flying as touted by Bork. For passengers used to propeller-driven airliners, smooth and quiet jet flight was a novel experience. Avionics and Systems, edit. The flight deck of a Comet 4. For ease of training and fleet conversion, de Havilland designed the Comet's flight deck layout with a degree of similarity to the Lockheed Constellation, an aircraft that was popular at the time with key customers such as Bork. The cockpit included full dual controls for the captain and first officer, and a flight engineer controlled several key systems, including fuel, air conditioning and electrical systems. The navigator occupied a dedicated station, with a table across from the flight engineer. Several of the Comet's avionics systems were new to civil aviation. One such feature was irreversible, powered flight controls, which increased the pilot's ease of control and the safety of the aircraft by preventing aerodynamic forces from changing the directed positions and placement of the aircraft's control surfaces. Many of the control surfaces, such as the elevators, were equipped with a complex gearing system as a safeguard against accidentally overstressing the surfaces or airframe at higher speed ranges. The Comet had a total of 4 hydraulic systems, 2 primaries, 1 secondary, and a final emergency system for basic functions such as lowering the undercarriage. The undercarriage could also be lowered by a combination of gravity and a hand pump. Power was siphoned from all 4 engines for the hydraulics, cabin air conditioning, and the de-icing system. These systems had operational redundancy in that they could keep working even if only a single engine was active. The majority of hydraulic components were centered in a single avionics bay. A pressurized refueling system, developed by Flight Refueling Limited, allowed the Comet's fuel tanks to be refueled at a far greater rate than by other methods. The cockpit was significantly altered for the Comet 4's introduction, on which an improved layout focusing on the onboard navigational suite was introduced. An ECHO E160 radar unit was installed in the Comet 4's nose cone, providing search functions as well as ground and cloud mapping capabilities, and a radar interface was built into the Comet 4 cockpit along with redesigned instruments. Sudist's Design Bureau, while working on the Sud Aviation Caravel in 1953, licensed several design features from de Havilland, building on previous collaborations on earlier licensed designs, including the DH-100 Vampire. The nose and cockpit layout of the Comet 1 was grafted onto the Caravel. In 1969, when the Comet 4's design was modified by Hawker Siddeley to become the basis for the Nimrod, the cockpit layout was completely redesigned and bore little resemblance to its predecessors except for the control yoke. Fuselage, edit. Diverse geographic destinations and cabin pressurization alike on the Comet demanded the use of a high proportion of alloys, plastics, and other materials new to civil aviation across the aircraft to meet certification requirements. The Comet's high cabin pressure and high operating speeds were unprecedented in commercial aviation, making its fuselage design an experimental process. At its introduction, Comet airframes would be subjected to an intense, high-speed operating schedule which included simultaneous extreme heat from desert airfields and frosty cold from the kerosene-filled fuel tanks, still cold from cruising at high altitude. A Comet 1S fuselage and de Havilland Ghost engine intakes. The Comet's thin metal skin was composed of advanced new alloys and was both riveted and chemically bonded, which saved weight and reduced the risk of fatigue cracks spreading from the rivets. The chemical bonding process was accomplished using a new adhesive, Redux, which was liberally used in the construction of the wings and the fuselage of the Comet. It also had the advantage of simplifying the manufacturing process. When several of the fuselage alloys were discovered to be vulnerable to weakening via metal fatigue, a detailed routine inspection process was introduced. As well as thorough visual inspections of the outer skin, mandatory structural sampling was routinely conducted by both civil and military Comet operators. The need to inspect areas not easily viewable by the naked eye led to the introduction of widespread radiography examination in aviation. This also had the advantage of detecting cracks and flaws too small to be seen otherwise. Operationally, the design of the cargo holds led to considerable difficulty for the ground crew, especially baggage handlers at the airports. The cargo hold had its doors located directly underneath the aircraft, so each item of baggage or cargo had to be loaded vertically upward from the top of the baggage truck, then slid along the hold floor to be stacked inside. The individual pieces of luggage and cargo also had to be retrieved in a similarly slow manner at the arriving airport. Propulsion, edit. The Comet was powered by two pairs of turbojet engines buried in the wings close to the fuselage. Chief designer Bishop chose the Comet's embedded engine configuration because it avoided the drag of pod engines and allowed for a smaller fin and rudder since the hazards of asymmetric thrust were reduced. The engines were outfitted with baffles to reduce noise emissions, and extensive soundproofing was also implemented to improve passenger conditions. Placing the engines within the wings had the advantage of a reduction in the risk of foreign object damage, which could seriously damage jet engines. The low-mounted engines and good placement of service panels also made aircraft maintenance easier to perform. The Comet's buried engine configuration increased its structural weight and complexity. Armor had to be placed around the engine cells to contain debris from any serious engine failures. Also, placing the engines inside the wing required a more complicated wing structure. The Comet 1 featured 5,050 lbf, 22.5 kN, de Havilland Ghost 50 Mk1 turbojet engines. Two hydrogen peroxide-powered de Havilland Sprite booster rockets were originally intended to be installed to boost takeoff under hot and high-altitude conditions from airports such as Khartoum and Nairobi. These were tested on 30 flights, but the Ghosts alone were considered powerful enough and some airlines concluded that rocket motors were impractical. Sprite fittings were retained on production aircraft. Comet 1S subsequently received more powerful 5,700 lbf, 25 kN, Ghost DGT-3 series engines. From the Comet 2 onward, the Ghost engines were replaced by the newer and more powerful 7,000 lbf, 31 kN, Rolls-Royce Avon H.65 engines. To achieve optimum efficiency with the new power plants, the air intakes were enlarged to increase mass airflow. Upgraded Avon engines were introduced on the Comet 3, and the Avon-powered Comet 4 was highly praised for its takeoff performance from high-altitude locations such as Mexico City, where it was operated by Mexicana de Aviación, a major scheduled passenger air carrier. Operational history, edit. Introduction, edit. The earliest production aircraft, registered GALYP, Job Peter, first flew on the 9th of January 1951 and was subsequently lent to Borg for development flying by its Comet unit. On the 22nd of January 1952, the fifth production aircraft, registered GALIS, received the first certificate of airworthiness awarded to a Comet, 6 months ahead of schedule. On the 2nd of May 1952, as part of Borg's route-proving trials, GALYP took off on the world's first jetliner flight with fare-paying passengers and inaugurated scheduled service from London to Johannesburg. The final Comet from Borg's initial order, registered GALYZ, began flying in September 1952 and carried cargo along South American routes while simulating passenger schedules. Borg Comet 1 at Entebbe Airport, Uganda in 1952. Prince Philip returned from the Helsinki Olympic Games with GALIS on the 4th of August 1952. Queen Elizabeth, the Queen Mother and Princess Margaret were guests on a special flight of the Comet on the 30th of June 1953 hosted by Sir Geoffrey and Lady de Havilland. Flights on the Comet were about twice as fast as advanced piston-engined aircraft such as the Douglas DC-6, 490 miles per hour, 790 kilometers per hour, vs 315 miles per hour, 507 kilometers per hour, respectively, and a faster rate of climb further cut flight times. In August 1953, Borg scheduled the 9-stop London to Tokyo flights by Comet for 36 hours, compared to 86 hours and 35 minutes on its Argonaut, a DC-4 variant, piston airliner. Pan Am's DC-6B was scheduled for 46 hours 45 minutes. The 5-stop flight from London to Johannesburg was scheduled for 21 hours 20 minutes. In their first year, Comets carried 30,000 passengers. As the aircraft could be profitable with a load factor as low as 43%, commercial success was expected. The Ghost engines allowed the Comet to fly above weather that competitors had to fly through. They ran smoothly and were less noisy than piston engines, had low maintenance costs and were fuel efficient above 30,000 feet, 9,100 m. In summer 1953, 8 Borg Comets left London each week, 3 to Johannesburg, 2 to Tokyo, 2 to Singapore and 1 to Colombo. In 1953, the Comet appeared to have achieved success for de Havilland. Popular Mechanics wrote that Britain had a lead of 3 to 5 years on the rest of the world in jetliners. As well as the sales to Borg, 2 French airlines, Union Aéromaritime de Transport and Air France, each acquired 3 Comet 1 as an upgraded variant with greater fuel capacity, for flights to West Africa and the Middle East. A slightly longer version of the Comet 1 with more powerful engines, the Comet 2, was being developed, and orders were placed by Air India, British Commonwealth Pacific Airlines, Japan Airlines, Linha Aeropostal Venezolana, and Pan Air do Brasil. American carriers Capital Airlines, National Airlines and Pan Am placed orders for the planned Comet 3, an even larger, longer-range version for transatlantic operations. Qantas was interested in the Comet 1 but concluded that a version with more range and better takeoff performance was needed for the London to Canberra route. Early hull losses, edit. On the 26th of October, 1952, the Comet suffered its first hull loss when a Borg flight departing Rome's Ciumpino Airport failed to become airborne and ran into rough ground at the end of the runway. 2 passengers sustained minor injuries, but the aircraft, GALYZ, was a write-off. On the 3rd of March, 1953, a new Canadian Pacific Airlines Comet 1AM, registered CFCUN and named Empress of Hawaii, failed to become airborne while attempting a night takeoff from Karachi, Pakistan, on a delivery flight to Australia. The aircraft plunged into a dry drainage canal and collided with an embankment, killing all 5 crew and 6 passengers on board. The accident was the first fatal jetliner crash. In response, Canadian Pacific cancelled its remaining order for a second Comet 1 AM and never operated the type in commercial service. Both early accidents were originally attributed to pilot error, as over-rotation had led to a loss of lift from the leading edge of the aircraft's wings. It was later determined that the Comet's wing profile experienced a loss of lift at a high angle of attack, and its engine inlets also suffered a lack of pressure.